Plot the points A, B, C, and D. Give the best description for this quadrilateral. Provide reasons that justify your conclusions. What are the angles? Why are those things? What are the side lengths, etc.? All right, so I'm going to start with A. A is at 1, 6. And I'll just make a very nice bold dot here. I will label this A, and I will also label it 1, 6. The next point is at 2, 3. So X is 2, Y is 3. And I will label this point B, and I will give it a 2, 3. Next we're at C, which is at 11, 6. Okay, 11, and then up 6. Interesting. And this is point C, and C lives at 11, 6. And the last point lives at 19, or 10, 9, 10, 9. So X is 10, Y is the number 9. Here we go. And this is point D. So this is 10, 9. So, interesting. A couple of things that we know is that this line right here has a slope. This line has a slope of negative 1/3. That's its slope. And across from that, if I look at this line DC, this line has the exact identical slope. Right, its slope is also negative 1, 3. So I know at this point it's at least a trapezoid, right? I've got slopes, one pair of opposite sides that have the same slope. So at least it's a trapezoid. Let me grab a ruler to make a cleaner line here. So for this next line, here you go. This virtual ruler sometimes seems like it's more difficult for me to use than it might be worth. But I'll just try and sketch that. And I'll try and sketch this down here. So these have this pattern of up 1 unit and then over 1, 2, 3, up 1 over 1, 2, 3, up 1 over 1, 2, 3. Okay, so this slope, right? I have the wrong slope here. This is the slope. This has a slope of positive 1/3. These have a slope of down 3 over 1. These have slope of negative 3. So those of you that are watching this, like if you were scratching your head like, hey, what's wrong with that guy? Well, that's what's wrong with that guy. I identified the wrong slope here. These are slopes of negative 3. But hey, they're still parallel to each other, so it's still at least a trapezoid. And this is 1/3, and actually here at 1, 1, 2, 3, up 1 over 1, 2, 3, up 1, 1 over 1, 2, 3. This has a slope of 1/3 also. So I know that these lines are parallel as well. So it's not just a quadrilateral. It for sure is a parallelogram because I have two pairs of opposite sides that are parallel. Right? Yeah, and you know what else? Because those slope patterns fit the same, right? I know these hypotenuses have to be the same. So without even calculating what they are, I know that that this line segment, actually it's the square root of 10. We just did this in a previous problem with the 3 and the 1. These are the same length, right? And the other one has a change of 1, 2, 3, and then goes over 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so these line segments are going to be congruent for the same reason also, right? They have the same legs that bind them together, same rise and run pattern. So those are congruent as well. So it's a parallelogram, and I think that's a property of a parallelogram is that both pairs of opposite sides are parallel and congruent, and we have that here. And then the final other thing that I want to show on this diagram is I want to just pull out and highlight the fact that this slope and this slope, they make something special happen. Those slopes ensure me that this has to be a right angle, right? Those two slopes are opposite and reciprocals of each other. And it doesn't stop there. It turns out the same thing is true for this adjacent slope, right? I've got 1/3 and I've got negative 3, opposites and reciprocal. And then same thing with these. So not only is it a parallelogram, right? Both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, but because we have 4 right angles there, this is a rectangle. Now, I've talked a lot, and I did not expect you to write all of that down, but in your diagram, if I saw things that were equivalent to this, if I saw your slope calculations or your slope labels like this, and some talk about parallel and stuff, I did not deduct any points, but writing out a couple sentences would be most beneficial. Just saying, adjacent sides have opposite reciprocal slopes, so they form right angles, right? Opposite sides are the same length by the Pythagorean theorem. Opposite sides are parallel because they have the same slopes. Saying those 3 things would be really all that's necessary there.